Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students! Today we are going to start with Class 10 Science and Technology Part 1, Chapter number 5, Heat. Topics that I am going to cover during this session are latent heat and the phenomena of regelation. We often use the word heat and temperature. But students, do you know the difference between heat and temperature? Heat is a form of energy in motion, whereas temperature is the degree of hotness or coldness of a body. Heat is a cause of temperature. It is the heat that causes a change in the temperature of the body. That is, because of the heat, the temperature of the body changes. Whereas temperature is the effect of heat. Heat does not determine the direction of flow of heat, whereas temperature determines the direction of flow of heat. It always flows from the body at the higher temperature to the body at the lower temperature. And finally, the unit for measuring heat is joule or calorie, whereas the units for measuring temperature are Celsius, Fahrenheit or Kelvin. Shown over here in the picture, you can see that the heat energy from the stove burner warms the water. But what will be the temperature of the water? It is determined by the thermometer. So, temperature at different points will be different. Unit of heat are joule in SI unit, whereas calorie in CGS units. The amount of heat necessary to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 calorie heat. Similarly, the amount of heat necessary to raise the temperature of 1 kg of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie of heat. And the relationship between the kilocalorie and calorie is 1 kilocalorie is equal to 1000 kilocalories. Now, let us understand the latent heat with the help of an experiment. As shown over here in the picture, take few ice pieces in the glass beaker. Insert the bulb of thermometer in ice and measure its temperature. Put the beaker on the stand and heat the ice using the burner. Record the temperature using the thermometer after every minute. As the ice is heated, it starts melting. Stir the mixture of the ice and water. Continue heating even after the ice starts melting. The water boils. Finally, you have to draw a graph of temperature versus time. Over here in this graph, it is mentioned that x-axis represents the time, whereas y-axis represents the temperature. Initially, you can see when the ice is in the solid state, the temperature is below 0 degrees Celsius. Now, you will observe that the temperature of the mixture remains at 0 degrees Celsius till the ice melts completely. In this graph, the line AB represents the conversion of ice into water at constant temperature. When the ice is heated, it melts at 0 degrees Celsius and converts into water at this constant temperature only. So, at the point B, the ice has converted into liquid. And now, if we continue heating even after the conversion of all the ice into water, the temperature of the water starts rising. You can see over here from B to C, the temperature is rising and it reaches at 100 degrees Celsius somewhere here at the point C. At this temperature, the water starts converting into steam. The temperature of the water remains constant at 100 degrees Celsius till all the water converts into steam. In the graph you can see over here the line CD, it indicates the constant temperature, that is at 100 degrees Celsius till all the water is converted into vapor. And after the point D, again the temperature will start rising. So over here what is happening is the ice initially absorbs the heat energy during this transition, and the absorption of the energy continues till all the ice converts into water. So the temperature remains constant during this transition. This constant temperature at which the ice converts into water is called the melting point of the ice, that is 0 degrees Celsius. Thus, during the transition of solid phase to liquid, the object absorbs heat energy, but its temperature does not increase. This heat energy is utilized for weakening the bonds between the atoms or the molecules in the solid and then transform it into the liquid phase. So this heat energy absorbed at the constant temperature during the transformation of solid to liquid is called the latent heat of fusion. Once all the ice is transformed into water, the temperature of the water starts rising. It increases up to 100 degrees Celsius. The line BC in the graph represents the rise in temperature of water from 0 degrees Celsius to 100 degrees Celsius. Thereafter, even though the heat energy is supplied to the water, its temperature does not rise. Over here see, it is indicated by the line CD. The temperature remains constant after 100 degrees Celsius. The heat energy is absorbed by the water at this temperature and it is used to break the bonds between the molecules of the liquid and convert it into the gaseous state. Thus, during the transformation from liquid phase to the gas phase, heat energy is absorbed by the liquid but the temperature does not change. The constant temperature at which the liquid transforms into the gaseous state is called the boiling point of the liquid. The heat energy absorbed at this constant temperature during the transformation of liquid into gas is called the latent heat of vaporization. So in general, we can say the amount of the heat energy that is either absorbed or released during the change of the state is called latent heat. And the heat absorbed at the constant temperature during transformation of solid into liquid is called latent heat of fusion, as we have seen earlier also. And the amount of the heat energy absorbed at the constant temperature by unit mass of solid to convert into liquid phase is called the specific latent heat of fusion. The heat energy that is absorbed at constant temperature during transformation of liquid into gas is called latent heat of vaporization. The amount of the heat energy absorbed at constant temperature by unit mass of the liquid to convert into gaseous phase is called specific latent heat of vaporization. Students, you may have seen the preparation of an ice ball. First, an ice slab is shredded and then the shredded ice is pressurized around the tip of the stick to prepare the ice ball. How does the shredded ice converts into solid ice ball again? If two small pieces of ice are taken and pressurized against each other for a while, then they stick to each other. Why does this happen? This happens because of the phenomena called regelation. Understand this phenomena with the help of an activity. Put a slab of ice on the stand as shown over here. Hang two equal weights to the two ends of a metal wire and put the wire on the slab as shown in the picture. What do you observe? It is observed that the wire gradually penetrates the ice slab. After some time, the wire comes out of the lower surface of the ice slab. However, the ice slab does not break. The phenomena in which the ice converts to liquid due to the applied pressure and then reconverts to ice once again when the pressure is removed is called regelation. The melting point of the ice becomes lower than 0 degrees Celsius due to the pressure. This means that at 0 degrees Celsius, the ice gets converted into water. As soon as the pressure is removed, the melting point is restored to 0 degree Celsius and the water gets converted into ice again. This is all for today's session. Thank you so much.